Hello, I'm Taeho Lee from Department of Environmental Engineering. It's a huge pleasure to be speaking in front of all of you today. I will present the work we've done in developing the real-time water quality simulation using machine learning and application programming interface. I'll divide my presentation into 4 parts, and I'm going to explain specifically about each of the parts. In order, first, introduction. It proves the purpose and necessity of the development. Second, in methods, we're going to show solutions and implementation process. Third, we're going to show achievements and results. Lastly, we're going to demonstrate our conclusion. First, introduction. As all of you might ever heard of, that increasement of micropollutants is growing concern here in Korea. Since river has played a vital role in human life and sustaining social developments such as drinking water, maintaining aquatic systems, and offers a recreational space for citizens. For that reason, the real-time water quality modeling must be accompanied to manage and protect the river from contamination. Therefore, we developed the real-time water quality simulation toolbox using machine learning and application programming interface. Okay, let's move on to second method. As I mentioned in previous page, our program utilizes the application programming interface, and we have adopted the use of random forest and artificial neural network techniques. Moreover, our system is user-friendly and features a graphic user interface, making it easily accessible for anyone to use. An API is a system that facilitates a communication between different software components. It acts as a messenger, allowing a client application to request the data from a server application and receive in a response. The API was used to obtain both weather and water quality data, and it was implemented using MATLAB as the programming language. And the two pictures here indicates the methods of simulation. One is RF and the other one is ANN. RF is a machine learning algorithm that falls under ensemble categories. It employs multiple decision trees to generate more reliable prediction. By aggregating the subsamples from the original data, RF finally constructs an individual decision trees. Unlike RF, ANN, which is inspired by biologically human brain, consists of numerous interconnected units known as nodes. As you see the picture on the right side, when input layer accepts the input data, each node is multiplied and transferred to a hidden layer, thus making the yielding of prediction result. This picture here shows the method of building prediction models. In order to forecast water quality values in advance, we utilize the data set that involved a one-day difference between data pairs. And this was achieved by shifting input data and output data by one cell. Also, we removed the last cell in the input data and the first cell in the output data to maintain the consistent size of the data. By repeating this process 3 times, it enables us to predict the water quality up to 2 days in advance. Following the acquisition of data from API, the weather data is first passed through the flow rate model. The resulting data, consisting of both weather and flow rate values, is then input into a water quality simulation prediction models. The output of these models is compared to the water quality values obtained from the API and plotted on the graph. This allows us to access the accuracy of our simulation prediction models. Finally, all models and procedures were integrated into a toolbox, and the system was developed into a graphic user interface called GUI. The study area is located on the Nakdong River, one of the South Korea's 4 major rivers, which is located in the southern part of the country. And this map over here is a map of Nakdong River basin in Korea. And blue circle indicates the water quality monitoring station. A yellow triangle indicates the flow rate station, and the red star indicates the weather station. Okay, now let's turn to the results. We demonstrated representative 3 stations water quality simulation through machine learning. And the graph in this page indicates the result of water quality using RF model. And the graph here indicates the result of water quality using ANN model. And Additionally, this graph here shows the result of XAI for Blonwa Station. The XAI has been proposed as a solution to address the limitations of traditional AI models. The inner workings of these models are typically opaque, leaving us with little insight into how predictions are made. However, the XAI addresses this issue by comparing the AI model to a simpler model and conducting mathematical analysis. By utilizing XAI, we can get a better understanding of impact of each input variable on the output prediction. Finally, during the development of this model, we came to several conclusions. First of all, the use of API ensured the stable acquisition of the latest data and enabled the effective utilization of large databases. Second, in environmental field, random sample data demonstrated more effective performance compared to the series data. Third, among ML machine learning algorithms, RF showed the best performance while most of the water quality exhibit reliable performance. RF showed the best performance. And fourth, while most of water quality exhibit a reliable performance, simulating CHLA and TOC, like total organic carbon based on only weather data, had still limitations. And building GUI is expected to enhance user convenience. And lastly, this process can save manpower and helpful to other diverse area. And the graph on the left side is a flowchart of developing water quantity and quality simulation toolbox using machine learning algorithm. And this is for end of my presentation, and thank you for listening, and thank you.